Today I'm going to be introducing OHDSITargets, which is a proof of concept extension of the targets framework for building analytical pipelines in R. Here's an example targets project. That's kind of a hello world example. In it we have an R folder with several functions. Here's a function that reads in some data, another function that fits a model, and then finally a function that creates a plot. The targets software is built around this _targets file, and in particular there is a list of targets. That's the last thing in this file. So we can see that the list contains several targets: the file, the data, the model, and the plot. And these things are going to get tracked by targets so that they can be updated, but only if downstream things change. We can see the dependency graph for this pipeline. We have a CSV file, and data object, a model, and a plot. tar make. We can see that each of the targets was built, and now everything is up to date. If I make a change to, say, the plot function, and save it, and then look at the network, we can see that the plot is now outdated. The code has changed, and so because the function has changed, the plot needs to be updated. So if I run tar make again, we can skip the steps that we don't need to rerun and only rerun the plot. To view the objects, these objects are stored in an _targets folder here. And to view them, you can say targets tar load everything. And then we have our plot object, which we can print out. What I've shown you is the process for creating single targets based on custom functions. Sometimes we want to create a large number of targets, and for that, Targets provides some extension packages like target types and stand targets that provide target factories, which can create a large number of targets. So our idea for this project was to look at building a similar extension to targets for OHDSI pipelines. So Martin Lavallée and I have worked on building this OHDSITargets package, and I can demo what we have completed so far. This is still in development and definitely a proof of concept, so it's installed directly from GitHub. Once it's installed, you should be able to go to New Project, New Directory, and there's these different project types, and there should be an OHDSI study pipeline target. we'll just create a new project on the desktop. So what you start out with is kind of a template OHDSITargets project with the _targets.r file. We're using the config file to record the database information. So here we have our study name. We have two databases that we want to run this project against, the Eunomia database and a local Postgres database. And this is where we'll enter our connection detail information as well as the names of the schemas. We have input information for our cohorts. So here we have several cohort JSON files as well as a CSV file that specifies the cohorts we're going to create and the IDs. The R folder is where we would put any custom functions that we want to include in our pipeline. Here's the basic targets file, and the list of targets at the end includes target factories. So instead of creating individual targets, we're going to create a large number of targets. For example, this cohorts factory will create one target for each cohort in the cohorts to create. And similarly, the cohort diagnostics target factory will create individual targets for each of the diagnostics. To run it, we just do the same thing. tar make. And we can see the pipeline running. In this case, it's running on Eunomia because we've set our active database to Eunomia. Okay, so we've completed our the pipeline build. To see all of the objects that were created and are now stored in the _targets folder, we can load everything into our R session. So we have a reference now, an object that's a reference to our cohort table. It contains the cohort table names and the timestamp of when it was created. This is so that if we ever rerun our pipeline, it's going to invalidate this object because the timestamp will have changed and cause everything downstream of it to be invalidated. We also have these generated cohort objects. So we're using 3 cohorts, and each one of them is tracked in R using a generated cohort object. It contains the ID, the name, number of entries, number of subjects, the cohort definition, and of course a timestamp of when it was generated. We can look at targets tar viz network. And get a look at the dependency graph here. So this will get messy as the number of targets increases, but we can see that we have these our files, which are JSON files. Downstream of the JSON file is the actual generated cohort object. There's 3 of them. And downstream of that are the various cohort diagnostics outputs, which are taken directly from the cohort diagnostics package. And so we can see when we're looking at something like cohort relationship, it depends on all three cohorts. So if any one of these changes, the cohort relationship needs to be updated. Just for an example, let's change one of the JSON files and make sure that it gets tracked. So here's the GI bleed. I'm just going to add a new line in here. Save it. So I didn't really change the cohort definition, but the file did change. Now let's run VisNetwork again. We can see that part of our graph has now been outdated, but not all of it. Cohort file 3 changed, and generated cohort 3 is now outdated, as well as any of the diagnostic information that that depends on cohort 3. So to refresh our pipeline, we can run tar make again. The nice thing about targets is that if I want to add in a custom step into the pipeline, I can just add another target here. The way to do this is to write your custom code in a function and save it in the R folder. In this case, I have a plot. I'm creating a plot of the incidence rate output just between the years 2000 and 2019. I have to choose one of the already created targets to pass in. We can see that now I've built the instance plot. And if I say targets, tar load, instance plot, I now have my plot. Thanks for watching my presentation. I think this is an interesting direction, but still in the proof of concept stage. And these are we're looking at how to best make use of targets for OHDSI studies. Thank you.